Storms on this continent were never gentle. Some arrived with walls of rain that turned paths into rivers. Some carried winds that bent trees sideways. Others buried entire valleys in snow so heavy it collapsed anything unprepared for it. Modern builders struggle with weather like this, even with synthetic sealants, engineered shingles, and waterproof membranes. Yet, long before any of those existed, Native American communities built shelters that stayed dry through everything the sky could throw at them. Across the Great Plains, the Eastern Woodlands, the Northwest Coast, the Desert Southwest, and the Arctic, people developed waterproofing systems so effective that their homes remained dry inside even during the fiercest storms. These methods weren't accidents. They were the result of sharp observation, testing, and a level of craftsmanship that turned natural materials into weatherproof armor. Cedar bark peeled in slabs that shed rain the way a fish sheds water. Birch bark layered with precision so tight it worked like natural shingles. Hide coverings angled and arranged to force runoff away from living spaces. Clay plaster applied smoothly enough to stop leaks even during days of continuous rain. Roof designs, domes, cones, and tapered slopes that pushed water off instead of letting it sit. Drainage trenches carved around lodges so that storms flowed away rather than into the home. Every region had its own solution, shaped by its climate. Every material had a purpose. Every shelter was built with storms in mind. If you've ever wondered how people kept their families dry without modern tools, if you want to see engineering built purely from natural materials and practiced skill, if you're ready to learn techniques strong enough to stand against blizzards, downpours, and snowmelt, you're about to step into one of the most underrated chapters of indigenous technology. Subscribe now, because every day we uncover ancient survival systems that outperformed expectations and still hold lessons for the world we build today. Before we dive into the specific techniques used across different regions, it's important to understand one thing. Native waterproofing wasn't a single method or material. It was a collection of innovations shaped by climate, geography, and generations of problem solving. Every region faced its own challenges. In some areas, storms carried sheets of relentless rain. In others, snow piled so high that the weight alone could ruin a poorly built roof. And in the West, sudden cloudbursts could flood the ground within minutes. Despite all this, shelters stayed dry. Not by luck, but by design. The first secret was material knowledge. Builders didn't just use wood or bark because it was nearby. They used specific types for specific reasons. Cedar bark, for example, contains natural oils that resist water. Birch bark, harvested correctly, creates panels that repel moisture as effectively as modern shingles. Clay mixed with sand and grass forms a plaster that seals cracks without crumbling. And tanned hides, arranged in overlapping layers, shed water like roofing tiles. The second secret was layering. Waterproofing wasn't a single barrier. It was a system. A wigwam or longhouse might have bark sheets outside, woven mats inside, and a frame that allowed air circulation between them. A teepee used multiple hide panels arranged to overlap, preventing wind from driving rain inward. In the Northwest, cedar planks were angled so runoff traveled downward instead of seeping through seams. The third and most overlooked secret was drainage. These communities understood that waterproofing begins before the roof is even built. Many shelters sat on slightly raised ground or were surrounded by shallow trenches to direct water away. A structure that channels water properly needs far less sealing overall. These techniques didn't rely on modern coatings or synthetic materials. They were the product of close observation, experimentation, and a deep understanding of how water behaves when it hits bark, hide, clay, or soil. When people imagine waterproofing without modern tools, They often picture something crude or unreliable. But native communities across North America used materials with natural properties so effective that even today, craftsmen study them for inspiration. Each material was chosen for what it could do, not just because it was available. Cedar bark was one of the most powerful defenses against moisture. Along the northwest coast, it was peeled in long, wide strips that retained their natural oils. These oils helped the bark resist rot, repel water, and maintain flexibility. When layered like scales, cedar bark formed a shell capable of shedding rain for years. Birch bark took waterproofing to another level. Tribes in the Great Lakes and Northeast regions harvested bark from mature trees, ensuring smooth, thick panels that could bend without cracking. When stitched with spruce roots and sealed with pine resin, birch bark became a natural version of modern roofing. Lightweight, watertight, and incredibly durable. Canoes made this way crossed stormy lakes without taking on water, so imagine how well it worked on a roof. Tanned hides played a major role on the plains. Bison hides, deer hides, and elk hides were softened, stretched, and treated to repel moisture. Once arranged in overlapping rows on teepees, they created a durable outer skin. Rain hitting the surface simply rolled downward along the slope, unable to find a gap. Clay and mud plaster dominated in the Southwest. When mixed with sand and dried grasses, the plaster became strong enough to seal entire homes. Applied in repeated layers, it filled gaps and formed a smooth exterior surface that stopped rain from seeping in. These walls didn't just survive storms. They absorbed heat during the day and released it slowly at night. Natural sealants completed the system. Pine pitch, animal fats, and plant resins were used to plug seams, waterproof joints, and reinforce vulnerable areas. These sealants hardened into tough, weather-resistant coatings. Together, these materials formed waterproofing systems remarkably advanced for their time. Powerful, adaptable, and built entirely from what the land provided. Waterproofing wasn't only about the materials. The shape of the shelter itself did half the work. Long before modern architects began using angled roofs, runoff channels, and aerodynamic forms, native builders designed structures that naturally forced water away instead of allowing it to pool, seep, or linger. One of the most intelligent designs was the cone-shaped teepee of the Great Plains. At first glance, its shape seems simple, but in heavy rain, the steep angle created a rapid downward flow, preventing water from sitting on the surface long enough to penetrate. Multiple overlapping hide panels acted like shingles, each one covering the edge of another. Even the smoke flaps on top were positioned to redirect rainfall rather than catch it. The entire structure worked like a natural storm-shedding machine. In the Eastern Woodlands, wigwams and longhouses used dome-shaped and arched frames. These rounded designs allowed rain and snow to slide and curve downward instead of collecting at the top. Birch bark sheets were placed with the grain running downward, creating vertical channels that guided water off the surface. Inside, a second layer of woven mats added insulation and kept interior spaces dry even during persistent downpours. Along the northwest coast, cedar plank houses were angled with precision. Roof planks overlapped generously, forming long sloping surfaces that carried water toward the back of the house. The weight of cedar, not prone to warping, kept everything tightly sealed. Builders even raised the rear edges of the roofs slightly to control the path of runoff. In the Southwest, earth-plastered homes used flat roofs but compensated with thick walls, drainage spouts, and fast-drying plaster mixtures that prevented moisture from penetrating deeply. The roof edges often had small channels that guided water away from doorways and living areas. Even underground dwellings, like those in the Arctic and subarctic, were designed with raised entrances and angled passages that kept meltwater out during warmer seasons. Across all regions, one principle stayed consistent. The shelter itself handled the weather before materials ever had to. Shape was strategy, and strategy kept families dry through the harshest storms. A shelter didn't become waterproof simply because it was built well. It stayed waterproof because people understood how materials aged, shifted, and reacted to weather, and they adjusted their homes long before problems had a chance to grow. Maintenance wasn't an afterthought. It was part of the building tradition itself. On the Great Plains, teepees required routine tightening of hide ties. When rainstorms arrived, hides absorbed moisture and stretched slightly. Skilled hands adjusted the lashing points, pulling panels snug again so no gaps formed between seams. After storms, hides were dried, re-softened, and occasionally retreated to keep them flexible and water-resistant. In the Eastern Woodlands, birch bark coverings were checked seasonally. Bark can age beautifully, but it can also crack under long sun exposure. Tribes replaced damaged panels and restitched roots around weakened seams. Because birch bark is naturally antimicrobial and long-lasting, a well-maintained roof could serve a family for many years. In the Northwest, cedar plank houses demanded surprisingly little upkeep, but not none. Builders would occasionally flip planks or replace those impacted by storms. Cedar contains natural oils that repel decay, but craftspeople still monitored warping, tightening lashings, and sealing gaps with a fresh application of pitch. In the Southwest, earthen and adobe structures required seasonal plaster renewals. Instead of ignoring small cracks, people mixed new clay, sand, and chopped grass and smoothed on fresh layers. These repairs sealed the home, strengthened the walls, and kept water from penetrating the plaster during monsoon rains. Across all regions, adaptability was constant. If weather patterns changed, building shapes changed. If new materials were discovered, designs shifted. People didn't cling to a single, rigid model. They modified shelters to match the climate each season brought. This ongoing care wasn't burdensome. It was simply part of life, a steady rhythm of observing, adjusting, and reinforcing. And because of that rhythm, these shelters remained dry, sturdy, and reliable through storms that would challenge even modern construction. One continent, 5 dramatically different climates, and each region produced waterproofing techniques perfectly tuned to its own extremes. This is where the ingenuity of native building shines the brightest, because nothing was copied from elsewhere. Every design came from reading the land, watching the sky, and learning exactly how storms behaved in each environment. The plains were famous for violent thunderstorms and horizontal rain driven by fierce winds. Teepees were built to answer this. Their steep angle forced water to rush off instantly. Overlapping hide panels acted like giant shingles, each layer protecting the one below. Even the wind worked in their favor. The round shape deflected gusts instead of catching them. Abundant rainfall meant woodlands shelters needed long-lasting armor. Birch bark was the perfect match. Its tight fibers repelled water, and when layered vertically, it became a natural drainage system. Longhouses often had multiple bark layers, stitched with spruce roots and reinforced with interior mats that stayed bone dry, even in weeks of rain. This region receives some of the heaviest rainfall in North America. Yet cedar plank houses rarely leaked. Why? Cedar contains oils that resist rot, mold, and moisture. Builders overlapped planks like siding, angled the roofs for runoff, and sealed seams with natural pitch. These homes stood firm through relentless storms. Rain was rare, but when it came violently. Adobe and earth-plastered homes used thick walls and hardened clay exterior coatings that shed sudden storms. Roof edges were carefully shaped to carry water away from entrances and gathering areas. Underground and semi-subterranean homes required raised entry tunnels and tightly packed sod coverings. As snow melted in spring, angled passages and elevated living platforms prevented moisture from entering the living space. 5 climates, 5 completely different approaches, all remarkably effective. Long before waterproof sprays or synthetic caulking existed, native communities had already mastered natural sealants capable of strengthening roofs, sealing joints, and turning vulnerable surfaces into watertight barriers. These substances weren't improvised. Each one was chosen for a specific task, prepared through careful steps, and applied with precision. Pine pitch was one of the most important sealants across the continent. Collecting it wasn't as simple as scraping sap from a tree. The resin was heated slowly over a fire until it thickened, then mixed with fine ash or powdered charcoal to create a durable, sticky compound. This mixture hardened into a black, glossy coating that resisted rain, snow, and extended moisture exposure. Canoe seams sealed with pitch held firm through choppy waters, so when used on shelters, it created joints that didn't just resist leaks, but reinforced structural strength. Tree resins varied by region. In the Northwest, spruce gum was harvested and softened with gentle heat until it became pliable. Applied along the edges of cedar planks or between bark layers, it formed an elastic seal that moved with the structure instead of cracking under shifting weather. In northern forests, the combination of spruce gum and animal fat produced a sealant that stayed flexible even in freezing temperatures. Animal fats played their own role. Rendered fats from bison, deer, or bear were brushed onto hide coverings to repel moisture and rejuvenate worn surfaces. Renewing hides with a thin layer of warm fat added resilience, darkened the surface to promote faster drying, and prevented stiffening during cold seasons. This simple treatment helped teepees and other hide-covered shelters shed water more effectively. Some sealants were applied with fingers, some with sticks, and others pressed into place using smooth stones. Regardless of method, the goal was the same: close every gap, reinforce every seam, and ensure that the next storm, even the worst one, would find no way inside. A shelter could have perfect materials and flawless construction, but without a smart drainage system, one heavy storm could undo everything. Native builders understood this deeply. Long before the first wall went up, they studied how water moved across the ground, where it pooled, how fast it flowed after rain, and which spots dried quickest. Choosing the wrong ground meant constant leaks. Choosing correctly meant a home that could withstand years of storms without a drop slipping inside. In the Great Plains, where sudden cloudbursts could turn flat ground into temporary lakes, teepees were often set on slightly raised mounds or gently sloped terrain. This elevation prevented water from sitting under the structure. Builders carved shallow trenches around the base, just deep enough to catch runoff and guide it away from the living area. These rings acted like invisible shields, keeping the ground beneath the teepee dry, even during intense storms. Woodland communities used another approach. Longhouses and wigwams were built on ground that naturally absorbed or redirected water. The surrounding soil was intentionally smoothed and packed to prevent erosion, and small channels were shaped along the outer edges to carry water away. Some sites were chosen near tree cover, where dense roots helped stabilize the ground and reduce flooding. In the Southwest, adobe homes sat on platforms of packed earth. Even small steps in elevation made a difference when rare but powerful rains hit. Builders edged the roof with slight inclines leading to drain paths, ensuring water spilled far from doorways. In the Arctic and subarctic, where snowmelt could drown a carelessly placed home, people constructed underground dwellings with raised sleeping platforms and entry tunnels angled upward. Meltwater drained away while the living space stayed dry. What's remarkable is that none of these drainage strategies required heavy digging or complex tools. They relied entirely on observation and small adjustments. Subtle shifts in slope, shallow pathways, or raised foundations that made the difference between a flooded shelter and one that remained dry through the harshest seasons. The roof was always the first line of defense against rain, snow, and freezing winds. and native builders approached this part of the shelter with a level of precision that turned simple materials into incredibly effective weather shields. Each region developed roofing systems tuned exactly to its climate, using shape, angle, and layering to keep water out no matter how severe the storm. The sharply angled teepee wasn't just elegant. It was mathematically brilliant. Its steep slope forced rain to run off instantly, never giving moisture time to pool or seep. Multiple hide panels were overlapped generously, each one covering the seam below it. Even the smoke flaps, often misunderstood as decorative, were positioned to divert rain away from the opening. When wind-driven rain hit from the side, the rounded shape redirected it, rather than catching it. The rounded frames of Eastern Woodlands shelters created natural runoff paths. Rain slid along the curved surface instead of gathering. Birch bark sheets were arranged like vertical shingles, allowing water to travel downward without finding edges to slip under. Inside, woven mats added a second layer of protection, ensuring the living space stayed dry during extended storms. Cedar planks, thick and naturally water-resistant, were laid in overlapping rows. Their weight kept them firmly in place even during gale-force winds. Roof angles varied by village, but all directed runoff toward the back or sides of the home. Sealed seams of spruce gum kept these roofs tight, so tight that some stood strong for decades without needing a full rebuild. Though flat roofs seem risky in rain, adobe builders compensated with genius. They mixed thick clay plasters that hardened into protective shells and added slight, almost invisible slopes to guide water to drain spouts. These roofs absorbed heat by day and dried rapidly after storms. Each roofing system wasn't just built, it was engineered with purpose, tuned to the storms that shaped each region. Rain was one challenge, but in many regions, winter brought an even greater threat. Snow could fall for days, piling higher than doorways and weighing thousands of pounds. A weak roof meant collapse. A poorly insulated structure meant frostbite. Native builders understood these dangers intimately, and their snowproofing techniques were nothing short of remarkable. People often imagine teepees collapsing under winter storms. In reality, when winter covers were added, these shelters held strong. Thicker, winter-treated hides created a denser exterior. Interior liners, stitched along the base, formed a warm air buffer, trapping heat while guiding cold drafts downward and out through the ground-level opening. The teepee's steep angle wasn't just for shedding rain. It prevented snow from accumulating heavily, forcing it to slide off before weight became dangerous. The woodland dome-shaped wigwam was a natural snow-shedding structure. Curved frames made from bent saplings spread weight evenly, eliminating weak points where heavy snow could break through. Birch bark didn't buckle under moisture. It froze into a protective shell that insulated the interior. Some longhouses had double-layered bark roofs that stayed firm under enormous winter loads. In regions where snowstorms were brutal and constant, people didn't fight snow. They used it. Subterranean homes, covered with sod and driftwood, were shaped to let snow pile on top. This wasn't a flaw. Snow became insulation, trapping warmth inside. Entry tunnels dipped downward and then upward again, preventing cold air from rushing into the main room. Raised sleeping platforms kept families above any moisture caused by melting snow. Even in the desert, winter storms struck high elevations. Adobe homes used thick clay walls that absorbed cold slowly and resisted cracking. Flat roofs, reinforced with wooden beams and coated with fresh plaster, held strong under moderate snowfall. Across all regions, snowproofing wasn't about brute force. It was about understanding weight, shape, and airflow. These shelters didn't just resist winter, they adapted to it. As you've seen, staying dry wasn't luck. It was skill. A skill built through observation, experimentation, and generations of refining techniques until shelters became stronger than the storms around them. From birch bark layered like armor to cedar planks that shed rain effortlessly. From hide-covered teepees angled with precision to adobe walls that sealed out sudden desert downpours. Every region created a waterproofing system that made survival possible in some of the harshest climates on Earth. These weren't temporary fixes or simple shelters thrown together in a hurry. They were long-lasting, adaptable, and carefully engineered. They stood against rain that could flatten fields, winds that could tear trees from the ground, and snow that came down so heavy it broke the backs of poorly built roofs. Modern construction still struggles with problems these communities solved centuries ago, and solved using nothing more than natural materials and hard-earned knowledge.